All right, so here are the big ideas that you're hoping to pull out by the end of all this. So, what are the basics of the nitrogen cycle? And more specifically, what is atmospheric nitrogen? What is ammonia? What are nitrates? What's nitrogen fixation? What is ammonification? What is nitrification? What is denitrification? You can tell there's a lot of similar words there, so we have to be careful there. Maybe flashcards are a good way to try to remember them. Which organisms can do ammonification? Which organisms can do nitrogen fixation? Which organisms can do nitrification? Which organisms can do denitrification? What are some ways human activity can affect each of the matter cycles we have discussed? And what are some ways each of the matter cycles we have discussed are interconnected? So really, we've seen that last one already, kind of. We're not going to explicitly discuss it. You should be able to kind of connect those based on what we've talked about in each one. For example, a water cycle pops up everywhere. All right, so we are going to look at the last of the matter cycles that we're going to discuss in Science 20, and that is the nitrogen cycle. It is the one that students usually find the most challenging, okay? But it is the same core idea. Nitrogen is matter that all living things need to live, and it gets cycled through living and non-living things forever, because all matter does, because matter is constant, right? We don't get more. We're kind of stuck with what we got, but it can change where it's sort of hanging out. Okay, so nitrogen is essential for life, just like carbon, water, and oxygen were. And the reason it is that it produces two things that you very much need to survive. The two things that nitrogen is very important for are proteins. Those are things that make your muscles, the enzymes that allow you to do a lot of bodily functions, like your spit is full of enzymes, your digestive system is full of enzymes, okay? And also nucleic acids, which is what makes up your DNA, so your genes, right? What makes you you? What gives you brown hair or blue eyes or whatever it might be? So you may have heard that 70% of our atmosphere is actually nitrogen. Great, okay, we got all the nitrogen we need, no worries. Except there's a problem. The nitrogen gas that's in our atmosphere, N2, atmospheric nitrogen, it cannot be absorbed by any organism. Any type of organism, producer, consumer, doesn't matter. Nobody can just breathe in nitrogen and use it for life functions. It's unusable in that form, okay? However, it can be used if first it's converted into a nitrate ion. So there's our first of our compounds we need to keep an eye out, NO3 minus. Okay, nitrate. And then if it's nitrate, plants can absorb it. Once again, it all comes back to plants, right? Plants are able to absorb nitrate ions, and then everything else, like you and me, get the nitrogen they need by eating plants, or eating the thing that ate the plants, or eating the thing that ate the thing that ate the plants. You know the drill by now, right? So how does N2, nitrogen that's up here in our atmosphere, atmospheric nitrogen, get to be nitrates, get to be converted into nitrates down here that plants can actually absorb? Well, basically, there's two ways that can happen, two ways that N2 can become NO3, and you see them here. So this process here, this kind of multi-step process, or this one-step process here. Realistically, this one does not do, this one here does not do most of it. It does a small percentage. This does the real heavy lifting, but we'll look at both of them really quickly, okay? So it can happen immediately by lightning, which seems kind of weird, right? That kind of seems out of place. Why lightning? It takes a lot of energy to combust N2, to make it burn like you would oxygen, okay? Lightning has a lot of energy. So lightning can offer enough energy to cause it to combust, which just means react with the oxygen, to immediately produce nitrates. So you see that happening here. The nitrogen in the atmosphere, when lightning strikes, it takes a little bit of that nitrogen, it turns it into NO3, which is now usable by living things and makes it into plants through their roots. Now that does happen, but the vast majority of nitrogen becoming nitrates happens in this second process, which consists of two main steps, okay? And it's done by first decomposers and then a special type of bacteria. So the step one is called nitrogen fixation or ammonification. It's actually two different things. They are they're the same end result, but they're a slightly different way of getting there. So ammonification is when any decomposer can do this, converts the nitrogen in dead organisms, so the nitrogen that's in their proteins or their enzymes or their DNA, like we set up here, right? They can break that down and turn it into ammonia, NH3. So that's what's happening here. Plants and animal waste and remains are being turned by any old decomposer into ammonia. So this is ammonification. And then same end result. So we're still going to get ammonia, but it's a little bit different. It's something called nitrogen fixing bacteria. They convert the N2 in the atmosphere into ammonia. So they don't do it from a dead thing. They do it from this stuff. So that's what's happening here. That's nitrogen fixation. And it takes a special kind of bacteria. It's not just any old bacteria. Okay, that's step one. So in step one, we went from some kind of N to ammonia. And that step could be either ammonification or nitrogen fixation. It depends which one you're looking at. What's important is that you know you go from unusable nitrogen to ammonia, okay? And then step 2 is where the magic really happens. Then you get another special type of bacteria called nitrifying bacteria. Nitrifying, different than nitrogen fixing, right? And they convert the ammonia into nitrates. And that is a step called nitrification. So NH3 becomes, remember what a nitrate is? NO3 minus, right? So where is that happening here? Notice the ammonia is becoming nitrates, NO3 minus. So this yellow arrow here represents nitrification, okay? I know the terms sound similar. You may have to make some flashcards or something to help you remember the difference, because nitrification is not the same as nitrogen fixation. Nitrogen fixation is step 1. Nitrification is step 2, where it actually becomes useful. So first that happens, and then nitrification happens. And now you've got useful NO3 minus that can be absorbed by plants. Okay, so just a reminder here of the important chemical formulas to remember. You got to remember N2. That's the stuff that's useless to living things, but it's everywhere. It's all around us. Kind of frustrating, isn't it? It's right there. You can reach out and touch it, but you can't use it for what you need it for. Okay, it becomes ammonia somewhere along the way, and then eventually, if it gets nitrified, it will become a nitrate, which can be absorbed by living things. If lightning happens to work on it, you can skip this step to this step, but reminder that most of it happens the slow way, not the fast way with lightning. Okay, vast majority happens the slow way. Okay, so just to practice this, get these terms down. Above each arrow, write the name of the process that is occurring. Below each arrow, identify what carries out the process. Okay, so if it's going from N2, atmospheric nitrogen, to ammonia. Okay, so ammonification would be if it was going from dead stuff, dead organisms, into ammonia. But this isn't. This is going from N2, straight from the atmosphere. So this is not ammonification. This is nitrogen fixation. And I should have said it at the beginning, guys. I really recommend pause the video here. See if you can fill in these arrows on your own. It's okay to do it with the notes, but you're probably going to get more out of that than by just listening to me do it. Okay, more helpful to you if you go back and practice now. You have the information you need to fill this out. Okay, nitrogen fixation. What's the special kind of organism that can do that? Well, that name is easy to remember because it's just the name of the process that's happening, essentially, right? It's nitrogen fixing bacteria. Okay, great. Now we've made ammonia, but plants can't absorb ammonia. Ammonia is basically what's in bleach, right? That would not be very good for plants. So that ammonia still needs a process to happen to it. Do you remember what it was called? Nitrification. And only a very special type of bacteria can do this. Again, they named it well because they just named it what it does. So it's nitrifying bacteria. Okay, and then we have something weird happening. We have some N2 that's going straight into becoming nitrates. What was that called? We usually call it atmospheric fixation or fixation by lightning because that's what does it, right? And what does it? Lightning. So at least the names kind of make sense. They're all kind of named after the process they do. All right. Now, do you see a problem with this? Does this look like a cycle to you? No, right? What's happening? Everything is making nitrates, making nitrates. What would eventually happen to the nitrogen in our atmosphere? It would run out, right? It's a cycle. So something must be happening that turns that NO3 minus back into N2. So there's one more process we haven't talked about, and that is denitrification, which is exactly what it sounds like. It's the backwards process of nitrification, except it doesn't turn it back into ammonia. It just goes all the way back to atmospheric nitrogen. A little confusing because it's not the exact backwards of nitrification, but it is undoing completely the last step, right? Which was just nitrification. Okay, so very creative biologists are, and they named the bacteria that do this denitrifying bacteria. And so this converts nitrates back into atmospheric nitrogen. This allows the N2 to not just run out, right? There's a balance between the nitrates and the nitrogen in our atmosphere. So it asks us here to add an arrow to the diagram above to show where denitrification fits in. Again, label the process above the arrow and identify what carries it out below the label. So again, probably try that on your own, but so denitrification is the process of taking NO3 and turning it back into N2. So that is called denitrification, and it's done by, very creative name, denitrifying bacteria. Okay, all right. Use the following information to answer the next 3 questions. A primary consumer dies on the forest floor. After two important biochemical processes, bio meaning living, but chemical meaning, well, chemical, so chemicals that have to do with living things, the nitrogen in its body will be ready to be absorbed by the roots of plants. All right, how did the primary consumer obtain the nitrogen that was in its body? Well, how did you obtain the nitrogen that's in your body? You could be a primary consumer, right? Eat a plant. Where'd you get your nitrogen? Well, you got it from your meals, you got it from your food. So, since it's a primary consumer, we can say it obtained it by eating a producer, right? If it wasn't a primary consumer, it would still get it from eating something. It's just it wouldn't have gotten it from eating a producer. It would have got it from eating a different consumer. And the producer, where did the producer get its nitrogen from? Oh, it's a producer, it's probably a plant. So it would have absorbed nitrates from the soil, right? Okay. What are the two important biochemical processes referenced in the source? So it just says that after two important biochemical processes, the nitrogen in its body will be ready to be absorbed by the roots of plants. So let's go back to this picture really quick. So we have animal waste and remains. So first, it has to become, do you remember what first stop is? That nitrogen in its body will first need to be turned into ammonia. By any old decomposer can do that, right? And we call that step ammonification. It's nitrogen fixation if it goes straight from the air to ammonia, but if it goes from something dead, it's ammonification. First, ammonification. And then, if we go back to the picture again, right? Ammonia is not good enough. We know that plants need nitrates to be able to use nitrogen. So, a special type of bacteria is going to turn that ammonia finally into those nitrates that those plants want, right? So, the next process is nitrification, done by nitrifying bacteria. So, nitrification is when NH3 goes to NO3 minus. Okay. Now, the source mentions that the nitrogen in the primary consumer's body will be absorbed by the roots of plants. Connect this information to your answer for number one to highlight the way in which matter moves through ecosystems. Aha. So we're saying that this little primary consumer, RIP, is going to be broken down into nitrates that will then be absorbed by a plant. Hey, where did we say that producer got its nitrogen from in the first place? Some plant, some producer, right? So it's a cycle. Eat a plant, die, become nitrates, get absorbed by a plant, right? Get eaten by something else dies, becomes nitrates, get absorbed by a plant, right? So it's a cycle here. So the primary consumer got its nitrogen by eating a producer, which absorbed its nitrates from the soil. Now the primary consumer is dead. It's going to become nitrates in the soil to be absorbed by some other producer, and the whole cycle will be done over again. Running out of room here. And on and on and on. That's the thing about cycles. We could go on all day about them, right? Because they never end. Hopefully, they never end anyway for us because they keep us alive. Okay, so that actually wraps up the nitrogen cycle. Let's just kind of big, broad view. There are tons of ways we could do a whole class on human impacts on ecosystems, obviously, right? But we're just going to look really quickly at some human impacts on the cycling of matter. Even that is going to be pretty superficial. We could go into way more depth on this, but we're just going to touch on it in a few ways here. So humans exist within the biosphere, right? We are not separate from the biosphere. We are living. Sometimes we like to act like we're not part of this biosphere. We totally are. There's nothing that special about us, really, right? We're sharing this biosphere with every other living thing on Earth. And so our actions have an impact on the processes that take place within it. When we affect the water, it's not like that's special water that's not part of the water cycle. No, every molecule of water on Earth is part of the water cycle, right? Our water isn't special or different. So there's many ways we can influence these matter cycles, but let's just take time to look at like literally a couple. Okay, we could go on all day about this. So if we look at the hydrological cycle first, okay, now look at the connection here to the carbon cycle. Notice the burning of fossil fuels. That sentence, the start of that almost makes you think we're going to talk about the carbon cycle here, right? But we're not. We're actually going to talk about the water cycle. Of course, in talking about the water cycle, it's hard not to talk about the other cycles because they are all interconnected. Okay, but it releases sulfur and nitrogen oxides, which can mix with the water vapor in clouds to form sulfuric acid and nitric acid. Okay, so you probably see which one makes which one. This then falls back down to the earth as acid rain. So you mix sulfur and nitrogen oxide with water, you get sulfuric and nitric acid. That falls back to the earth as acid rain. Acid rain is very damaging to ecosystems for many reasons, right? I know sometimes when you think of acid rain, you picture faces melting and trees completely getting disintegrated, which if it's bad enough can happen, right? Maybe not completely disintegrated, but acid can physically damage trees and stuff, but it also, even just a little bit of acid rain can lower soil pH or lower pond pH or a whole number of other things. And organisms are actually very sensitive to pHs. If you ever had fish, you know this, right? If your tank pH is off by just a little bit, all of your fish will not make it. Okay. More than that, acid rain can cause erosion of rocks and release carbon in those rocks. Hey, connection to the carbon cycle. Acid rain, not good stuff. Irrigation is a way that humans impact it. So, irrigation is when you basically remove water from a natural body of water to do whatever you will, usually to enable crop growth, usually for watering crops. And this is great if you live in a place without much rain and you're a farmer, right? But what it can do is disrupt the natural flow of bodies of water through ecosystems. So, if there's a river that many organisms rely on for a habitat or a water source or you name it, right? Or not just a water source, but remember, if there's water, plants will grow there, right? Organisms will rely on those plants. And so removing just the water is not saying, oh, they can find somewhere else to drink. Well, there might be a lot more to it than that, right? That might be the place where predators come to hunt their prey because they know prey will be there to eat. And if it dries up, they don't know where to go to hunt anymore, and predators can starve off. Another big impact of irrigation is that it can lead to the transport of chemicals into bodies of water through runoff. Hey, there's that word from the water cycle, okay? We call that leaching, when water essentially carries chemicals to bigger bodies of water. This is especially an issue when we talk about agriculture and irrigation, right? Because we use a lot of fertilizers in agriculture, right? In farming. And so all those fertilizers can get to bodies of water. When we talk more about the nitrogen cycle, human impacts, we'll see what can happen then. But essentially, we're taking the chemicals we use for farming and shipping them up the river down where they're going to accumulate in the ocean, because there's tons of farms where maybe one farm isn't going to affect one little creek too much. But if every farm on every creek that all feed one lake, well, eventually that lake's going to get a lot of stuff building up there, right? Okay, hydroelectricity is another way that we impact the water cycle, because for hydroelectricity, you have to dam rivers, right? Which really slows down their flow. This can be a real issue for ecosystems that are downstream from the dam because there's not enough water, right? Kind of like we just talked about before with the irrigation, except it can be even more extreme with damming. But it also causes issues for them upstream. A lot of rivers, remember, ecosystems develop over many years. So everything kind of fits into a role and finds its niche and gets used to it, right? Imagine if you woke up in a completely different city where we drove on the other side of the road and everything was just different, right? You would have a hard time adjusting too. You might not know where to go get food, right? You not know how to go ask someone for a meal. Just changing things overnight by flooding it can have a big issue. Yes, there's still water, but the same kind of plants can't grow because the water's not constantly flowing. It's flooding, and different plants like those conditions. And so the things that eat those plants are thrown out of whack, right? Remember, from our food webs, ecosystems develop into a pretty delicate balance where everything has a role, and making one little shift can have a huge chain reaction. Okay, some impacts on the carbon and oxygen cycle. The big obvious one is the burning of fossil fuels, right? We release carbon dioxide into the atmosphere in amounts that have never been seen before. Tons of it, literally tons and tons and tons of it. And this has dramatically increased the amount of CO2 in the atmosphere. It is far beyond the level that natural carbon sinks are capable of reabsorbing, right? Natural carbon sinks, what are those? Those are things like the ocean, rocks, things that absorb more carbon from the atmosphere than they emit into the atmosphere. Remember, the only living thing that can remove carbon from the atmosphere are producers, because they can do photosynthesis, which no consumer can do, right? Otherwise, we would do it. We can only add more CO2. So by putting this quote unquote artificial CO2 that's not even part of our life process, we really, really speed things up in terms of putting it out there. Okay, some human impacts on the nitrogen cycle. So this one asks us a question. Harvesting crops leads to nitrogen loss and disrupts the nitrogen cycle. Why? Why would harvesting crops disrupt the nitrogen cycle? Well, when we looked at the nitrogen cycle, how did the nitrogen in living stuff eventually end up being reused again? Well, it had to die and get decomposed, right? If you're a farmer, do you just let your crops die and let them sit there and get decomposed? No, right? You can't. You wouldn't be a very good farmer, right? You have to harvest the crops, remove them, but then that nitrogen goes off, gets sent to you or me, and we eat it for dinner. And we don't go to the farmer's field and get buried there so that our nitrogen can be returned to the ecosystem, right? So that nitrogen has been forever removed from that area. Okay. So you could probably think, well, if you're a farmer, what do you do? Because you can get one crop, but then next year you're not going to have any nitrates to support your crop's growth. Well, luckily we have something called fertilizer. Fertilizer is a few things. It's got some phosphorus in it, but by far it contains a lot of nitrogen. So looking at this picture here, remember we said atmospheric night fixation takes a lot of energy? It does. That's what this factory is doing. It's taking atmosphere from the nitrogen, putting in a lot of heat and pressure, and it's actually making fertilizers, which is basically human-made nitrates. Okay, human-made from nitrogen gas. So they are essentially a concentrated form of nitrates and other nutrients. Okay, and they're used to restore nutrients and increase production because you're going to remove that stuff that would naturally go back into the cycle to go sell it at market. Okay, so it allows their farmers to supply their soil with nitrates even though the natural cycle has been interrupted. This is great. This is very good for farmers. It's good for you and me who also rely on the farmers, right? However, it can also lead to something called an algal bloom or an algae bloom, okay, which is essentially when spring runoff, again, connections to the water cycle, right, carries decaying plant matter, and the big one is fertilizer-rich soil to streams, okay? Then the streams carry it to lakes and stuff. And you might be thinking, well, what's the big deal? Plants love nitrates. Well, yeah, they do. Algae really loves nitrates. Algae is a plant, right? It's a producer. So you're right, it does love it. And algae is an important part of an ecosystem. But have you ever heard of too much of a good thing is a bad thing? Well, that's the case here, okay? The sudden increase in nutrients allows algae and water to grow rapidly. And I mean crazy rapidly. Like overnight, you can see a lake go from nice and clear and blue to green. You don't want to get in it when there's an algae bloom, okay? Now, this already, the fact that it's grown like crazy can be very harmful to the system because the algae uses up resources, right? If there's too much of one organism, that's always a bad thing. You never want it to be that unbalanced. It also can block sunlight from getting through the water. So good for the algae that it can grow like crazy, but every other plant that's down at the bottom of the lake, well, what are they supposed to do without sunlight? They're all going to start dying off. And anything that doesn't eat algae, that's going to start dying off. Okay, so already it's bad news, but then things get even worse. Okay, this algae bloom will eventually start to die off because there's not going to be enough to sustain that forever, right? That is unsustainable population growth. So when they die, bacteria need to decompose them. Well, good, that's their job. Okay, that can return some nutrients, hopefully. However, bacteria are living things and they use oxygen. Pop quiz, do you remember what the name of the process is that they're doing that uses up oxygen? Cellular respiration, okay, from the water decompose them. So suddenly all of this decomposition, that's going to make oxygen levels drop quickly. So now fish and other animals are going to begin to die because there's not enough oxygen for them to survive. And well, why did this oxygen drop in the first place? Because decomposers had to decompose dead stuff and they were using up oxygen to do it. Oh my goodness, now there's a bunch of dead fish and animals, dying animals. That makes it even worse because bacteria must break these down as well. Now, this allows the population of bacteria to grow even larger and use even more oxygen. So you get a whole bunch of decomposer bacteria in the lake, which should always be there to help matter cycling, but too much of anything is a bad thing in an ecosystem. I'm going to show you a quick time lapse of an algal bloom, and you can kind of get a feeling for, ooh, that doesn't look good. That looks like too much of one organism. Looks like they're taking over the entire lake ecosystem, which doesn't leave any nutrients or resources for everybody else. Now, deforestation is a big one, okay, that I do want to at least mention. However, I'm not going to go through it because I think this is one that I would like for you to go and think about on your own and get thinking about the cycles and how deforestation would have an impact. So this is in your practice assignment, the deforestation question. I really do encourage you to go try that one. Think about matter cycles, think about human impacts, particularly this deforestation one. And if you're really stumped, my solutions are always posted for those as well. Okay. All right. And that wraps up topic 2. So here are the big questions. Hopefully you can answer now. What are the basics of the nitrogen cycle? What is atmospheric nitrogen? What is ammonia? Nothing too fancy there, just the symbol basically, and where it fits into the nitrogen cycle. What are nitrates? Same thing there. What is nitrogen fixation? So when I say that, tell me what the product and the reactant are. Again, same for ammonification, same for nitrification, and same for denitrification. Which organisms can do ammonification? Which organisms can do nitrogen fixation? Which organisms can do nitrification? Which organisms can do denitrification? What are some ways human activity can affect each of the matter cycles we have discussed? And what are some ways each of the matter cycles we have discussed are interconnected? So a little bit of reading between the lines on that last one. Okay. Okay, so if you're looking for practice, try out the topic 2 section of the practice assignment for this week.